Myself, RABINDRA Pradhan, lecturer in physics, Nalanda Plus 2 Science College, Brahmapur. Today, I want to teach on topic heat and thermodynamics. First of all, introduction. What is science? Science is an organized, systematic and formulated knowledge which is gained through observation, experiments and verification. What is physics? Physics is the branch of science which deals with the study of matter and energy. Physics is the natural science because it explains the laws of nature. Physics is also known as science of measurement. Heat and thermodynamics. Heat and thermodynamics is the branch of physics which deals with the study of conversion of heat into mechanical work and vice versa. Apart from this heat and thermodynamics, there are other branches of physics like mechanics, optics, sound, electrostatics, electronics, modern physics, etc. Heat is a form of energy which produces the sensation of hotness or coldness in us. For example, if we touch an ice, heat flows from our body to the ice, so we feel cold. Similarly, if we stand near a fire, heat flows from fire towards our body, so we feel hot. Heat gained by body is taken as positive, while heat lost by body is taken as negative. What is calorimetry? The branch of science that deals with the study of measurement of heat is called calorimetry. The device used to measure heat is called calorimeter. Temperature. The degree of hotness or coldness of a body is called temperature. The temperature of a body is a physical quantity which determines whether the heat energy flows from one body to another body or not. Thermometry. What is thermometry? The branch of physics science which deals with the study of measurement of temperature is called thermometry. The device used to measure the temperature of a body is called thermometer. There is a difference between heat and a temperature. Heat is a cause, but temperature is an effect. Means, if there is no heat, there will be no temperature in the body. So, here heat is a cause, but temperature is an effect. Heat represents total kinetic energy of the molecules of a body, whereas the temperature represents the average kinetic energy of the molecules of the body. There is also another difference between heat and temperature. Heat is a form of energy which flows from higher temperature of body towards lower temperature of body. But a temperature determines whether the heat energy flows from one body to another body or not. Students, temperature scales. There are different types of temperature scales, particularly 5 types of temperature scales: Celsius scale, Fahrenheit scale, Kelvin scale, Reaumur scale, and Rankine scale. Celsius scale has low fixed point 0 and a upper fixed point 100. So the interval 100 is divided into 100 equal parts each equal part represents 1 degree Celsius. Fahrenheit scale contains lower fixed point 32 and upper fixed point 212. So interval 180 is divided into 180 equal parts. Each part represents 1 degree Fahrenheit. Kelvin scale contains lower fixed point 273 and upper fixed point 373. The interval 180 is divided into 180 equal parts. Each part represents 1 Kelvin. Riemann scale contains lower fixed point 0 and upper fixed point 80. The interval 80 is divided into 8 equal parts. So each part represents 1 degree Riemann. In the Rankine scale contains lower fixed point 492 and upper fixed point 672. The interval 180 is divided into 180 equal parts. Each part represents 1 degree Rankine. The equation for conversion of temperature from one scale to another can be written as C minus 0 upon 100 minus 0 equal to 8 minus 32 upon 212 minus 32 equal to K minus 273 upon 373 minus 273 equal to Rankine RE minus 0 upon 80 minus 0 equal to RA minus 492 upon 672 minus 492. So here 0 in Celsius scale, 0 is the lower fixed point, means at this point ice melts, and here upper fixed point is 100, means water boils at this point. In Fahrenheit scale, at 32 is the lower fixed point at which ice melts, and upper fixed point is 212 degree at which water boils. Similarly, for Kelvin scale, Riemann scale and Rankine scale. So this equation can be simplified to the equation as C by 100 equal to 8 minus 32 upon 180 equal to K minus 273 by 100 equal to I by 80 equal to RA minus 492 by 180. So this is the required equation by using which we can convert temperature from one scale to another scale. Students, we can use the conversion equation in these questions. First question, convert 20 degree Celsius temperature into Fahrenheit and Kelvin. Solutions to this question can be made by using conversion equation, that is C by 100 equal to 8 minus 32 by 180 degree equal to K minus K minus 273 by 100. So here temperature is given in degree Celsius. So can you, in place of C, can add 20 by 100 equal to 8 minus 32 by 180. Using this relation, we can find out the value of 20 here of 100, that is 1 by 5, 8 minus 32 by 180. Solving this, here 5 f minus 160 equal to 180. That is 5f equal to 180 plus 160 equal to 340. Therefore, f equal to 340 by 5. So the value is 68. Okay. So the 20 degree Celsius equal to 68 degree Fahrenheit. 20 degree Celsius is equal to 68 degree Fahrenheit. Similarly, using this relationship, that is C by 100 equal to K minus 273 by 100. Using this, C by 20 by 100 equal to K minus 273 by 100. So your 1 by 5 equal to K minus 273 by 100. By cross multiplication, 5K minus 1165 equal to 100. So the 5K equal to 12,1265. Therefore, K equal to 1265 by 5. So value is found as 2 253. So here we can conclude that 20 degree Celsius equal to 253 Kelvin. Understood? So this is the answer to this question. Next question. At what temperature the readings of both Celsius and Fahrenheit scales coincide? So here also we can use this conversion equation. Celsius C by 100 equal to f minus 32 by 100. So let C equal to f equal to x. Let C equal to f equal to x. So putting this value, the value for C and f as x in this equation, we can find the value as x equal to minus 40. So here at minus 40 degree Celsius, as minus 40 degree Celsius equal to minus 40 degree Fahrenheit. That means at minus 40 degree Celsius and Fahrenheit scales must coincide. That is x equal to, by solving this using this equation and solving, we will get x as x equal to minus 40 degree. Therefore, answer is minus 40 degree at minus 40 degree Celsius and Fahrenheit scale coincide. Okay, coincide. Next question. Normal temperature of a human body, as you know, is 98.4 degree Fahrenheit. Find the temperature on Celsius and a Kelvin scale. Similarly, this question can be solved by using this conversion equation. C by 100 equal to f minus 32 by 100. So here, f in place of f, we can put the value 98.4 degree. 98.4 degree. And if solving this equation, we can find the value of S, value for C as C is found as 36.880 degree Celsius. 36.880 degree Celsius. Okay, and using this equation, that is C by 100, sorry, this equation, F minus 32 by 180, K minus 270 by 100, by using this relation and putting the value as 98.4 in place of F, we can find the value of K as so here 309.880 kg. Okay, right. Similarly, Fahrenheit and Kelvin scales coincide at 574.6 degree. Okay. Next, students, there are different units of heat such as calorie, kilocalorie, BTU, that is British Thermal Unit, and therm. 1 calorie, one value for 1 calorie equal to 4.2 joules. 1 kilocalorie equal to 10 to the power 3 calorie. 1 British Thermal Unit equal to 252 calorie. Here we have to know what do we mean by calorie. 1 calorie is the amount of heat required to rise the temperature of 1 gram of water from 1 degree Celsius. That is from 14 degree Celsius to 15 degree Celsius. So here 1 therm equal to 10,000 BTU. BTU means British Thermal Unit. British Thermal Unit. Okay. So here 10,000 BTU equal to 2.52 into 10 by 7 calorie. Because you have 1 BTU equal to 252 calorie. So 10,000 BTU means here the value is 2.52 into 10 to the power 7 calorie. Next, students, there are different units of temperature, namely Celsius, Fahrenheit, Kelvin, Reaumur, Rankine. The relation among these 5 units of temperature is given by C by 100 equal to F minus 32 by 100, F minus 32 by 180 equal to K minus 273 by 100 equal to RE by 80 equal to RA minus 492 by 180. By using this relation, we can convert the temperature from one unit into another unit. Next, students, equivalence of heat. There is an equivalence of heat. According to Joule, work is converted into heat and vice versa. Means heat can also be converted into work. The work done W is directly proportional to the heat produced. Work done W is directly proportional to the heat X produced in a body. That is, W is directly proportional to X, which implies that W equal to Jx, implies that J equal to W by X. So J is here, J is called Joule's mechanical equivalent of heat. Here J is proportionally constant, known as Joule's mechanical equivalent of heat. So this Joule's mechanical equivalent of heat, J, is defined as the amount of work done to produce a unit quantity of heat. Means if we heat X equal to unit, 1 unit, then J equal to W. So the definition of Joule's mechanical equivalent of heat is the amount of work done to produce a unit quantity of heat. The value of J is found as 4.2 calorie. Joule per calorie. J, the value of Joule's mechanical equivalent of heat J equal to 4.2 joule per calorie. Next.